All right, so starting on page 109, friends, we are again multiplying with 0, 1, 2, 5, and 10. So when we were looking at this lesson earlier in the week, we did find and discuss a number of things about multiplying with 0, 1, 2, 5, and 10. Specifically, we talked about counting or forward counting. And we talked about how those multiplication facts are skip counting or forward counting. And so there are lots of different ways that these questions can be presented. And for right now, let's take a closer look at this one on page 109. In a minute, I'm going to share my screen and we're going to talk about it as review. All right, so just give me 1 minute to get it up on screen for you. So what you are seeing on the screen is page 109. This is the start of session 2, multiplying with 2, 5, and 10. And so we are presented here with a word problem. And it is saying specifically that a company makes a toy robot that has 2 antennas and 5 buttons. How many antennas and buttons are needed for 6 robots? There are a number of different ways that you could approach this. A really awesome strategy, of course, is to build models. But please see that in this question, you have a number of things going on. All right? So the first important piece is that you are going to see that you need 6 robots or groups. You need 6 robots, and each of those robots has 5 buttons and 2 antennas. So what you need to know, what it's asking you is how many antennas and buttons, okay? How many antennas and buttons is the question. 2 antennas and 5 buttons for each robot. So you could break it up into 2 steps. You could start with antennas and then work your way down to buttons. That is one great strategy. So if we know we have 6 robots and we want to do buttons first, then we could start there.
What page is it?
Friends, please do not unmute yourselves. Please stay muted. And it is page 109. And I am drawing, friends, but again, there is some lag on my iPad. So what I have started with is 6, I guess we're going to call them groups, right? 6 groups or 6 robots. All right. And from there, we are going to give each of those robots 2 buttons. And then I'm going to go down. Oh, I'm sorry. It's 5 buttons. And I still need to do antennas. So I'm going to make my groups again. And again, friends, on the buttons, it is 5 buttons. There's a lag in my iPad. You're going to need to put 5 buttons for each robot. The correction you'll see on the screen in just a minute. The next group is coming. You're going to want to make a second grouping, but this time it's going to be antennas. You see many of you writing, awesome. All right, so sometimes in situations like this, it's easier to do it in steps. So you can see now that I have all the buttons that I will need for 6 robots, and I have all the antennas that I will need for 6 robots. And now in order for me to find out how many buttons in all that I need, I can add up all of these groups or skip count with the buttons 5, 10, 15, 20, 25, 30, right? And for the antennas, it would be 2, 4, 6, 8, 10, and 12. Could I write corresponding multiplication sentences to explain what I'm looking at? Yes, I could. Yes, I could. Because I would have 6 groups of 5, and that would give me 30 buttons, and I would have 6 groups of 2, which would give me 12 antennas. Could I draw an array? Yes, I could. I would have 6 rows, and then I would have 5 in each row. Lots of different ways, friends, that we can model this forward counting or skip counting or adding equal groups with multiplication. Okay? You're going to see the multiplication sentences coming up in just a minute. And once you see that, you'll be able to write that down, and then we will come back together and we're going to discuss this a little bit. And you will need whiteboards as well. Wow, the iPad is really slow today. I'm very sorry about that. In bringing together everything that we've talked about the last couple of days, I am going to give you an expression and we're going to break it down. All right. So let's say I give you 5 times 10. 5 times 10. I am going to need you to build an array that will display this. 5 times 10. Remember, number of groups, number in each group, what the rows represent, what the columns represent. All right, I need an array that will show that. Please do not solve it. Do not find a product or sum. I just simply need the array. Please hold them up when you're done. Again, do not solve it. I should not be seeing a product or a sum anywhere on your boards. Right now, we are just breaking it apart and taking a look. Sophia, please make sure that you do not have a product or a sum on your board. So again, friends, this is what we're looking for. You have 5 groups of 10. 5 are the rows. 1, 2, 3, 4, 5. 10 are the number in each group. Now, friends, I want you to make these equal groups. 5 equal groups. 5 equal groups. Make it 5 equal groups. Five equal groups, my friends. 5 equal groups. Now, could I skip count by 10 to get the total? So we have 10, and then 20, and then 30, and then 40, and then 50. Yes, I could. Could I simply solve and find the product? Yes, I could. I have 5 groups of 10. That product is 50. Some students find it useful to write the skip counting down on their equal groups. So if you write smaller than me on your whiteboard and you have more room, you will see on the sides, you can do that too, where you can say 10, 20, 30, 40, 50, if that helps your brain. If that helps your brain. Now, friends, what I do want to remind you of in this situation is that we could represent this product in a different way. We could, instead of 5 groups of 10, we could have 10 groups of 5. We could. Now, friends, the big idea here is that the total number of whatever this is, pieces of candy, pieces of gum, jelly beans, playing cards, doesn't matter. The total number that you have does not change. It does not change. The way that you group it up, that's what changes. 5 groups of 10, 10 groups of 5. Doesn't matter. The number is the same. You could have 2 groups of 25. Same total. Does everyone see that? That's the point with this. Okay? If we were in the classroom, we'd be doing all sorts of things and flipping boards around and playing with things that we could find in the classroom. But does everyone see this? Give me a quick thumbs up if you do. The total number doesn't change. You could have 2 groups of 25. You could have 25 groups of 2. That would be a very long array. But the total number is the same. All right? Okay. Okay, friends, so on page 113, you have this group of tomatoes. And so the question is, if you want to follow along with me as I read, Wes has 3 rows of tomato plants. There are 5 plants in each row. How many tomato plants does Wes have in all? Now, lots of different ways that we could solve this, right? We could simply count every tomato. We could do that. We could also skip count by 5 because we have 3 equal groups of 5. 5, 10, 15. We could also write down the multiplication equation, 3 times 5. We could prepare equal groups and solve it. Many different ways. You can see the tomato, they're already in an array. So the book has done that part for us. The idea behind it is that there are many different ways to model and solve, many different strategies here, friends. All right, so take a look at question number 1 under the tomatoes. And it's saying circle equal groups of 2. And then fill in the blanks to show the multiplication fact. So friends, are you going to do that now? Yes, you are. And I'm going to do it with you. Let's follow those steps. Circle equal groups of 2. Again, going back to those close strategies, you have 2 different questions to answer here. Make sure we're doing both. So when I close read, these are the types of things I like to do for my brain. 2 different questions. So the first one is fill in the blanks. That's my question 1. I put a little 1 next to it because that helps my brain. And then I need to fill in some blanks. That's 2, right? So I make sure I do all of it. So I'm going to do my equal groups of 2 first. So here are my equal groups, right? Equal groups of 2. Not a trick question, I promise. It's just equal groups of 2. So I did that part. And so I can say, I'm done with that. So I take my red pen and I make a check mark because that reminds my brain, I already did that. It's done. I've answered that question. And then it says to fill in these blanks. So it's saying, if you want to follow along, blank groups of blank is blank. So blank times blank equals blank. Doesn't that sound terrible? All right. So the first thing we need to figure out, how many groups of 2 do we have? You can just unmute yourself and tell me if you see it. How many groups?
6.
We have 6.
6.
So that's our first blank. 6 groups of 2.
2.
That's our second blank. So friends, already when you're seeing 6 groups of 2, your brain should say, oh, I can skip count that. I can forward count that. I could say 2, 4, 6, 8, 10, 12. Okay, that's my third blank. 6 group of 2 is 12 because I forward counted and I got that sum, right? So 6 times 2, that product is 12. That's what we're doing. Skip counting and finding the sum, or finding the equal number of groups and how many are in each group and finding that product. One will check the other. You can always check your work. Now, friends, another question I get is it okay to do these sentence starters? Is it okay to build those sentence frames when you're working? Of course, it absolutely is. Is it okay that you have to make an equal grouping and then show me the repeated addition? Of course. Do you want to show me an array? It helps your brain. Of course. Make a little organizer for yourself, whatever works for you. If it works for you, works for me. I want you to understand and be able to apply it. All right? So, it looks like this. 114. And it looks like blueberries. Is it blueberries? Yes, it's blueberries. I love blueberries. Now, questions 4 and 5. This is our first view of multiplication facts. Under 4, you're doing the facts for 2. Under 5, you're doing those facts for 5. So this is what I want you to do, my friends. This is my challenge for you. 2 things. I would like you to fill in both of these tables. And then I'd like you to be prepared to share with the class what you observed, what you see as you're completing this table and this table. Does that make sense to everyone? I'm going to give you just a couple of minutes to complete it, and then we're going to discuss it. When we complete this, these tables, these are for our 2 facts and for our 5 facts. And so when we take a look at the products that you've come up with, for the 2 facts, for example, who would like to tell me what they noticed, what they see, and what they're experiencing as they complete the table? Adon, go ahead.
It's like 0, 2, 4, 6, 8, 10, 12. It kind of like skip counting by 2s.
That's exactly what it's doing, Adon. Nice job. It's skip counting. How many of you noticed that? We start with 0, and then we go 2, 4, 6, 8, 10, and so on. We have 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2, 5 groups of 2. Could you model every single one? You could. As you get more what we call fluent in your multiplication facts, you won't need the models anymore. You will read your facts and know your facts the way that you read a textbook. That's what we call fluency, friends, where you don't need those models anymore. Very nice, Connor. I'm seeing that right now. Jerry, beautiful. Yep. And so who would like to share what they noticed about the 5s? Who would like to share that? Odin, go ahead.
It skipped counting by 5s
It's
instead of 2.
Yeah. Thank you, Odin. That's exactly what it's doing. We start with 0 and then 5, 10, 15, 20, 25, 30. Yes, we will have 1 group of 5, 2 groups of 5, 3 groups of 5, 4 groups of 5, 5 groups of 5, and so on. Again, could you model each of those expressions and equations? Of course you could. Will there come a point where you don't need to anymore? Definitely. Okay. How many of you are seeing that pattern? How many of you are seeing that? You can give me a quick thumbs up if you are. Excellent. Excellent. All right, friends. Now we are going to go on to the next session in our math, and I'm going to introduce something new to you. Friends, page 115. Now we are looking at session 3 in lesson 5. And so way up at the top, again, the text feature of bold print. That's where our eyeballs need to be right now. It says that John says 6 times 1 equals 6. Jeff says 6 times 0 equals 6. Who's right? So this is where we're going to take a minute and you are going to try to explain to me with models who's right, John or Jeff. I'm going to give you a minute to do that and then we're going to talk about it. Okay, my friends, so let us talk about this question. John says 6 times 1 equals 6. Jeff says 6 times 0 equals 6. Who's right? We need to have that explained. Who would like to try to explain it? Isis, go ahead, please.
John is right because 6 times 1 is 6, and Jeff is wrong because when you times 0, the answer should always be 0.
Thank you. And Isis, do you have a model that shows what you just told me? Did you draw a model? Okay. And I saw another hand. Anad, go ahead, please.
So I know that John is right because if you can see that the number of groups is 6 and the number in each group is 0. So the number in all should be 0, not 6.
Beautiful, Anad. Beautiful explanation. Thank you so much. That was very clear. Adan, did you have something to share?
Yeah, so John is right because 6 times 1 equals 6 because 6 groups of 1. And Jeff is wrong because 6 times 0 is 0 because if you have 6 groups of with nothing in them, you can't multiply it. And if you have 0 groups, you can't do anything. So John is right.
Wow, Adan, beautiful, absolutely beautiful. Very thorough, very complete sentences. You and Anad just did an amazing job on this. And Isis, just amazing. Thank you. Odin, do you have something to share?
If you multiply something with 1, it is the number that you are multiplying besides 1. And John is right because of something times 1, which I just explained, is right.
Thank you, Odin. Wow, friends, super impressed. Super impressed. So yes, it is John that is correct because, friends, it is telling us, John is saying that 6 times 1 equals 6. He's telling us he has 6 groups with 1 in each one. Jeff is saying that he has 6 groups with nothing in them. You have nothing to add, right? So friends, when we're taking a look at, up here at the top, we're looking at John. He has 6 groups. There's 1 in each one. So of course that equals 6. If we want to skip count, 1 plus 1 plus 1 plus 1 plus 1 plus 1 will equal 6. If we want to do the multiplication, 6 groups of 1, or 6 times 1, is 6. Now, if we go to Jeff and we model those same 6 groups, but Jeff has nothing to put in them. So friends, if we skip count, 0 plus 0 plus 0 plus 0 plus 0 plus 0, we have nothing. If we use multiplication, 6 groups of nothing, it's still nothing. And this is what we're going to be talking a little more about right now. Multiplying with 0 and 1. And what that looks like. Is everyone following so far? Particularly with the explanations from Isis, Anad, Adon, and Odin. All of you were just spot on, so thank you. Nice share out. Okay, if I were to give you this expression, how many of you could put words to it? How many of you could explain what you see? Let me show you. If I were to say, what does this mean? What does this expression mean? How many of you could put words to that and tell me what this means? Sophia, go ahead.
I would say 7 groups of 0 equals 0 because anything times 0 would equal 0.
Yes, thank you. And I'm loving the complete sentence. I'm loving that complete sentence. You're putting the question in the answer, learning that strategy, reminding us of that strategy that we were using a couple of months ago. So friends, would it be the same if I were to say, I have nothing? Is that an accurate interpretation of this? If I were to say, I don't have anything. How many of you think, yeah, that's accurate? Miss D doesn't have anything. Give me a thumbs up if you think so. Give me a thumbs up. Yes, friends, it is accurate for me to say, I have nothing. I have 7 groups of nothing. All right? So if I were to say, five times 1, would it be accurate for me to say, I have 5 of something? How many of you think that that's accurate? Now we're going to go a little bit deeper. I'm seeing Sophia right now putting yes up to the camera. So how many of you could explain why I have 5? Again, friends, we can always use our modeling strategies. We could always do that. So if you needed, if I was asking you to explain why this is 5, could you do something like, this and say, well, Miss D, you have 5 because you have 5 groups of 1. Maybe I have 5 little teeny tiny bowls and I have 1 jelly bean in each bowl. If food makes you happy in explanation, use food. Use candy. Use whatever makes you happy. As long as you can explain to me why. And now Sophia's becoming, she's an artist over here now. She's inspiring me because she just like drew a thumb up. Because y'all know I'm not an artist, but shh, don't tell me. All right, so going back to 0, if I were to say, 4 times 0. Could you model it in a way to explain that? Yes, you could. How would you model it? You would model it like this. I have 4 groups of nothing. I have very sad, very empty jelly bean bowls right now. Because I have 4 bowls, nothing's in them. I'm hungry and I'm sad. Okay? 4 groups of nothing. Remember, friends, doesn't matter what we're multiplying by. That first factor will always identify the number of groups that you have. The second factor is going to identify how much you have in each group. You can't add nothing, friends. You can't add nothing. I have 4 groups of nothing. Here's my challenge. Here's my challenge. If I were to say, I have 0 groups of 4, or 4 times 4. How would that be modeled, friends? Who could model this for me? I have no groups of 4. I have no groups of 4 right now. Adon, go ahead.
You couldn't do that because you would just have nothing. You can't. There's 0 groups. There's 0 groups, and there'd be no place for the 4 to go because there's 0 groups.
Adon, you are on point today. Yes, that is exactly 100% correct. I would do nothing. I'm done. 0 groups of 4. That is my explanation. I don't even have any groups at this point. I have nothing. Now, friends, there are lots of different properties that explain this. Lots of different properties that explain it. So when we talk about how 0 times 4 and 4 times 0 have the same product, that's what we call the commutative property of multiplication, which simply means we can flip those factors back and forth, but the product is the same. Our groupings are going to look different. Remember our arrays, and we were doing this, right? Our groupings are going to look different, but our product is going to be the same. That's called the commutative property, all right? And then we have something called the identity property of multiplication. So the identity property states that any factor multiplied by 1, any factor multiplied by 1, that product is going to be the other factor. The other factor doesn't lose its identity. The product will always be the other factor. That's the identity property. It does not lose its identity or who it is. It stays true to itself. It doesn't change. We also have something called the 0 property. The 0 property of multiplication, which simply states that any number multiplied by 0 is nothing. Doesn't matter which order, doesn't matter the groupings, doesn't matter. Any factor multiplied by 0. The 0 property says that product is nothing. All right? Commutative property, the factors can move back and forth. The groupings change, the product does not. Identity property, any number multiplied by 1, the product is the other number, it does not lose its identity. 0 property of multiplication, any factor multiplied by 0, that product is nothing. It is 0. All right. And in fact, and yes, I will be posting this onto my website later. I have some of these properties on a chart because y'all know I love charts. I'm not an artist, but I love math. So will this be on my website later? Yes, it will. You're seeing the 0 property. You're seeing the identity property. You're seeing the commutative property. It will all be there for you, friends. All right.